Hello, welcome to Topper Machine. I'm Josh Topper. So you're probably wondering why I have the chuck off right now, and mostly it's so I can clean behind it so we can get on with the job at hand. So today's job is to take these 6 chunks of 3.5-inch 1045 cold rolled and turn them into rollers that match this one. It's got a short stub on this end, and then a longer stub on this end with a hole through it. Looks like a 3/8 hole. I'll have to measure that. I made these quite a few years ago. This is for a local steel processing plant, and we even experimented back then with hollow rollers, and the hollow rollers did not hold up well at all. We had to do it out of the solid stock. These have held up extremely well. I can't tell you how many millions of pounds they probably run over these, but they have not failed. The failures they're seeing now are from bearing failures and not being caught and then chewing into the stub shaft. So we're just going to go ahead and make them 6 new ones. And we've got the chuck off so that I was doing some boring, and as you can see, the chips build up inside the chuck there. I got to get this all cleaned out, and then we're going to put in the sleeve into the spindle and use that as a stop for the bars. So we're going to slide them in to a solid, rigid stop and use the steady rest to support them. So that's how we're going to do it. That'll give us our lengths. Well, that's an interesting little problem. The 3-jaw that came with my lathe will not fit over this. I would have to use the 4-jaw. That'll fit over it, but for speed, I want to use the 3-jaw. So I think we're going to have to go about this differently. My goal was to set it up as a rigid stop, bring in the part, butt it up, face off the end, flip it around, butt it up, face it, measure it, and then finish the length. And then all of them would be the same once we set our 0. So now I'm going to have to come up with a slightly different solution here. All right, so I did some measuring, and we've got a 4-inch bore here. This is about 4 3/4, and this is something I would do frequently because I actually will do this on my other machines where I'll use the center or something like that in the 3-jaw. So what I'm going to do is I'm going to actually turn this down to just under 4-inch and flush, or just a little beyond flush. Just to make this difference so that the chuck does fit on there, and then we'll be able to go to work. All right, I'm just going to start by measuring just to see where we're at. And I mean, it'll give me a rough idea. About 450. So we'll take that down about 450, and then we'll take and move it down. We're going to go just under 4-inch. We'll probably go actually to 4 7/8. And we are at 750, 4 750. So 3 7/8 would probably be a good number to go to. And one more thing we're going to do as a safety factor is I've made up some of these out of aluminum. And it's just basically a center pusher block. And that'll hold some tension on it so that, because that's just a taper, it might want to walk loose. So we're just going to put a little tension on to hold it in place just for safety. All right, and then just because I don't know what this material is, how hard it might be, I'm only running at 355 RPM. We'll just take a cut and see what it does. I'm going to touch it off on the side here. There, 0 the readout, and I'm going to touch the face, and then 0. take 100 thou just to start. And we're going to go in 870 thousandths. And that is hard stuff. I was kind of afraid of that, it was hardened. So we're going to slow it down even more. I'm going to drop it down to 90. And I guess we'll get some coolant going. Let's get some more light in there. All right, now the chuck should fit on there. That'll work good for us. It's still usable as a 6-Morse taper pilot, but it'll also work with our 3-jaw chuck, so that's much better. All right, I got the steady rest up here. I got my lifting magnet. This is how we'll get the bars from the pallet onto the lathe so I don't have to try to lift them. And so let's go ahead and get the first one up there. Now I'm going to get a lot of people saying I'm doing this wrong, and you know, 25 years of doing it this way, and I have yet to have a problem doing it this way. I just bring them in till they're snug, and it's running pretty true, which it is, and cold rolled is quite good as far as trueness. Not much to worry about there. Go ahead and bite that one down. Take a little on that one. And we'll tighten up my top one here. Well, looks like it's running pretty good. And I'll go ahead and face this end. Need to speed that up. I'd say that's pretty good to me. Looks square, true. All right, we'll go ahead and flip it around and we'll face it off to length. So my finished length is 60.5, and it's fractional on the drawing, so it's plus or minus a 32nd, which is wide open, so we'll just measure it with the tape measure. No need to bring out the 72-inch vernier caliper. And I've got about 3/16 to go. I cut these a little long, but yeah, just over 3/16. I'd say 195 thou to take off. So go ahead and take that in 2 passes. Perfect, 60.5. As close with a tape measure as I can get, which is all they needed for this length. All right, next we'll go ahead and just swap it out and do the rest of them, get them all face to length. We're not gonna center drill them. There's just no point. We'll do all the work with the steady rest and it'll come out just fine. So I was just about to pull it out and throw the next one in there to face it to length. And I just thought about it, that's kind of silly. It's a fractional on the length, you know, the distances, it's not a big deal to just measure each one, cut them to length. If this were a much smaller part, then yes, pulling it out and going to your dedicated stop each time is a good idea, but on something this heavy, it's not worth it. So we're gonna go ahead and we're gonna make up our chip deflector here. That's not cutting that well. All right, let's try this again with a real hammer. Something that'll give me us a little cut. There we go. All right, we got our chip deflector up there. Still running a 355. I'm just gonna touch off here. Get an idea where we are. And then we need to go to, we're gonna do the short end first, which is 2 1/4 inches long. We'll come down and make a mark. And I'm gonna try to take 200 thou, 100 thou aside. I'm feeding it 20 thou revolution. That's cutting good, so we'll keep going. We've got for 3 1/2, got to go down to 1 1/4 inch, so we got a little ways to go. Alright, so I got distracted by a visitor here and I didn't have to cool the part. I'm at 1 1/2 now. I'm going to take it down another 200, and then I'll cool it. I'm going to stop short here in my corner because I'm going to put a radius on there. So we have a transition radius, so I'll just stop short, leaving some meat to work with. So we'll just go ahead and keep on cutting here. Alright, it is starting to warm up, so I'm just going to run some coolant on it. Once I get some coolant flowing here. Alright, we're cooled right off. I'm going to go ahead and take another 30. I slowed down my spindle speed, or my feed rate. Another 20 to go, so we're right on. We'll take that last 20 for just a short distance, just to verify. You know, we went a little bit far on that, so I'm just going to double check here. Touch off again and just see. There we are. Yeah, somehow we got a little deep. I don't know how that happened, but we're good now, so we'll go ahead and finish this off. And I've decided that instead of switching to a radius tool, I'm just going to hand radius that. It's not critical, so it's not going to matter. All right, let's see if our bearing goes on. She's snug. It's a little warm. I think once it cools off, it'll go right on. But I could always polish it with a little emery cloth. Try it the other way here. Yep, I think just a little bit of polish maybe. All right, let's see what we got here. Nice fit. Nice and snug. And it's still a little warm, so that'll cool off a little and that'll work great. Now we'll just put a chamfer here and a chamfer here, and this end is done. All right, that end's done. I'll go ahead and I'll flip it around and we'll do the long end. Well, I got it all flipped around or bottomed out on the 2 1/4 inches I took off, so we should be able to see that compensation down here when we touch off. We should see the difference. And that'll still allow us to hold that stop as our end, just resetting the digital readout for each cut. We got to take 4 1/4 inches on this one, down to 1.5 inches, and then we got a little step. So we got a radius in that 1.5 inches. So we'll go ahead and start cutting that. So I'm just going to touch off and see where we are. 2.25, so 2 1/4. Well, we got to go in 4 1/4 on this one. I'm just going to make my mark right there. I'm going to run a slower feed rate on this batch, and I'm going to go 250 thou, 250 deep on each pass. All right, she's all cooled off. We're down to our 1.5 inches. The next is to do my step here at 3 5/8, down to the 1.25 inches. It's nice and cool. I slowed down my feed rate, and we got about 41 to go. I'm gonna take 20, and then we'll check it with the micrometer and finish it off. $11 7/10 to go, so. I don't know if you can see that, but we're just about 5/10 under, perfect. I left a little bit here at the end so I can cut a radius. There, and we'll cut this radius here. let's see how our bearing fits. Beautiful. Nice and snug. That'll work great. All right, well, I'm gonna get it up out of here. I'm gonna enlist Connor's help to help me get it over to the Bridgeport, and then we'll get this drilled, and this one will be done. All right, I got it over here on the Bridgeport. We're just setting it on the table in the T-slot, using that as the guide. I made myself a rigid stop with just some clamp blocks butted up against. I indicated that, so I have my 0 point. I'm at the distance from the end to drill my hole. And now I'm just gonna find the side, split the difference, and drill the hole. All right, I got my screw machine drill in there. We'll just put a little spot of anchor lube right here. And we'll go ahead and drill it. Now, I run these screw machine drills for one main reason, is they don't wander as much as a jobber drill. So when you're doing, work like this on shafts or, just about anywhere, screw machine drills are the absolute best for this kind of application because they're much more rigid, they got a thicker web, they don't wander. All right, so last thing, I'll just take the file, just knock the burr off of the hole. The customer asked me not to chamfer it because there is a roll pin that goes through here and it holds a sprocket on for driving this. This is a driven roller. So the bearing goes on first and then the sprocket with the roll pin. So if we chamfer it with the chamfering tool, you take out more material. So they want as much engagement with that roll pin as possible because there's quite a bit of torque on these sometimes. So that's what we'll do. So this one's done. I got 5 more to go. I hope you enjoyed the video. Until next time, get out in your shop and get it done right the first time.